Hello, everyone, and welcome to the Environmental Finance Center's Wastewater Treatment Works educational video series. My name is AJ, and I am a research engineer with the Southwest Environmental Finance Center. Today, I will be going over a typical volume and flow problem a wastewater worker might encounter. I would first like to mention that this is the type of problem a wastewater operator would encounter during a wastewater operator certification exam. But anyone working with wastewater calculations should be able to solve this type of problem and can benefit from this type of knowledge. First of all, today, I'm going to introduce our problem that we're going to be working with, and it is based on wastewater volume and flow. So here's our question that we're going to be going over today. You've been tasked with assessing whether a rectangular lagoon system can be emptied at a sufficient rate using the available pump. The pump has a capacity of 40 gallons per minute. The lagoon's dimensions are as follows. It has a length of 250 feet, a width of 100 feet, and a depth of 6 feet. And the question that you need to answer, or the questions, can you determine the lagoon's maximum capacity in millions of gallons? Furthermore, what flow rate measured in gallons per minute is required to empty the lagoon within a 20-day period? And finally, can the available pump meet the required flow rate to completely empty the lagoon within the given time frame? Also, as a bonus, can you identify the type of a lagoon this pond is? To start the problem, we're going to first find the volume. So the first part of the question is, what is the volume of the rectangular lagoon? We know that the volume equation for a 3D rectangle is going to be that the volume is equal to the length times the width times the height. And sometimes it's useful to draw this out. So I drew a 3D rectangle, and then we were given the length, the width, and the depth of the lagoon. So we could add those values to the different sides. So we can see that we have a length of 250 feet, a width of 100 feet, and a depth of 6 feet. Also, to solve this problem, we need to know that the question asked for the volume in gallons. So that is a measure, that's a unit of volume. But the volume that we're going to come up with first is going to be cubic feet. So it is useful to know that there are 7.48 gallons per cubic foot. Okay, now that we know the variables that we have, we can solve our problem. So we have our equation laid out here, and we can set it equal to the values that we have. So we have our length, so our volume is going to be equal to 250 feet times our width, which was 100 feet, times our depth, which is 6 feet. If we plug this into a calculator, this equals 150,000. Those are our numbers. And the feet, the units multiplied by each other, we just multiply 1 foot by another foot, which is feet squared, times another foot is feet cubed, or 150,000 feet to the third power. Now we need to convert this to gallons. So we will take our 150,000 feet, or cubic feet, and multiply this by our conversion, which is 7.48 gallons per cubic feet. So our cubic feet will cancel. And this will be equal to 1,122,000 gallons. And this is equal to 1.122 million gallons. Now on a test, you probably wouldn't get this many significant figures, which is the number of values that we used. We used 4 digits, the 1.122, that's 4 digits. You might usually get about 3 or even So this, you might see this as 1.12 MG. So we solved this beforehand, before this video, before the presentation, and you can see that the calculations are the exact same. And this could be good to go ahead and go over on your own. So it is asking us, what is the required flow rate in gallons per minute to completely empty the lagoon in 20 days? Additionally, can the pump that's available meet the required flow rate to completely empty the lagoon in the required time frame? And if you recall, this was a 40 GPM pump. Now our equation for flow is going to be our volume over time. And this is a 20-day period, and per day there's 1,440 minutes. So that's an important information that we're going to use on this as well. So to solve this, we're going to take our equation, our flow equation, and we're going to plug in the numbers that we have. So first we need to figure out what is the time frame. We know that our time is equal to 20 days. We need to convert this into minutes because the problem asks for us to report this in gallons per minute. So we're going to use a conversion. We know that there are 1,440 minutes per day. So then we multiply this 20 days times 1,440 minutes, and that is equal to 28,800 minutes. We then will find our flow, which again is equal to our volume over time. Or we found our volume earlier, and we're going to do this in gallons as 1,122 gallons, 22,000 gallons over 28,800 minutes. So we plug that in our calculator, and it comes out to 38.958 GPMs. This would probably be rounded to 38.96 GPMs. And 38.96 GPMs is less than 40 GPMs. So the pump would have enough capacity to completely empty the lagoon in the required time frame. And again, we did these equations beforehand, so we can show that 20 days times 144 minutes is equal to 28,800 minutes. And if we divide our flow by that, we get 38.96 GPM, which again is less than the max capacity of the pump, and we'd be able to completely evacuate the lagoon. Finally, our bonus question. What type of lagoon pond is this? So pond is another name for lagoons. It's typically used in the wastewater field. Now, aerobic ponds are typically designated as 3 to 5 feet in depth. Anaerobic ponds are identified as greater than 14 feet. And facultative ponds are 4 to 8 feet. Since we were given the information on this that the depth was 6 feet, this type of pond would be a facultative pond. And that's all we have for today. So thank you for joining us, and please look forward to our next videos.